we're going to find the derivative of a certain function. But let's talk about this symbol because now it's going to mean something more to us. Do you remember back when we first learned derivatives, we listed like a whole string of ways that we could say derivative? And this was one of them. So we talked about how the d meant delta because slope is like our delta y over our delta x. And so this was telling us we're taking the derivative of y with respect to x. Well, that's set up to be in an explicit form. We're taking the derivative of a y equals equation with respect to x. Okay, well now let's just change that a little bit. Another way that we had a form was something like this. So another form was we could have d over dx, and then in brackets, we would have our function. So what this is asking us to do is it's asking us to find the derivative of 3x. This is still telling us we're in terms of x. We're with respect to x. X, another way to say it, x is our independent variable. Okay, now we have all these shortcuts at our disposal. So like before I started muddying the waters right now, if I just said what's the derivative of 3x, you would say 3. And that's easy enough because we are just dealing with x's. The thing that we're going to be paying more attention to now is these variables match. The variable that we're with respect to is the variable they're asking us to derive. Okay, well today we're going to switch that all up and maybe we'll have something like this. And so it's still asking us to find the derivative with respect to x, but we're not with respect to x right here. These variables don't match. So what we do is we still use the rules that we know. All of these weeks we've been learning our derivative rules. This is like a constant multiple rule. But because of the different variables, we have to attach, it's like a little conversion factor. It's technically a chain rule. And whenever we derive something, when it's not matching the variables, we're going to multiply it by or just kind of stick beside it this dy dx. And so we're saying we just took the derivative of a y, but we were with respect to x. So anytime we get those y's now, we're going to have to also attach beside it this little dy dx. Now I'm going to say something this next 30 seconds might not make sense. So if it doesn't, just erase it from your brain. But technically, what we were doing up here, even though I never said it, is we were taking the derivative of an x when we were with respect to x. And what's dx over dx technically going to give us? 1. We just never had to talk about it before because we never mixed up our variables before. So now when we switch variables, what variable are we taking the derivative of over what are we with respect to? Okay, now let's make it more complex. That's like 3y. That's not much. Let's try this one. So we're going to be with respect to x. And now let me have us find the derivative of x squared plus 6y. So one of the rules that we've learned power rules, product rules. We also learned the sum or difference rule. So we're allowed to look at each of these separately. And so if we start with x squared, if we just think about just how it would flow off your tongue, what's the derivative of x squared? Well, we would say 2x. These variables match, so we just leave it like normal. Okay, plus, okay, 6y, if we think about all of our rules, when we would derive that, it would just be a 6. But now because the variables don't match, we attach a dy dx there. And that's the basic idea. Of course, you know I'm going to show you like some complex issues to it, but this is the basic idea of what we're doing with implicit differentiation. Okay, now this next one I'm going to show you is the one we just always have to be careful of. People just kind of always float by this without thinking too much about it. Let's find the derivative with respect to x of x cubed y to the fourth. Okay, don't we have two things that are being multiplied together? So overall, this is going to be a product rule. So we're going to follow that product rule layout, but whenever we derive our y's, we have to attach that extra little thing. So for product rule, we'll do the first times the derivative of the second. So we'll take the derivative of y to the fourth. Just think about it as a nice little power rule. 4y cubed. But then that was deriving a y. So we're going to put a dy dx there. Plus the second times the derivative of the first. So the derivative of x cubed, 3x squared. Why don't I have a dy dx next to this y? It's not derived. It was in its original form. How are we feeling so far? It's kind of weird. Feeling okay? All right. Let me show you this next one. And this is going to be where this will be more like how they look. So let me write it out. We are going to find dy dx when we have the equation y cubed plus y squared minus 5y minus x squared equals -4. So this is actually more like how they're going to look. And that's because this is an equation. So instead of them just giving us a little expression that we derive, most of the time it's going to be an equation that we have to find our derivative of. And you'll see right from the get-go that we've got like a bunch of x's and y's and they're all kind of mixed together. The key that you know that you're going to have to do implicit is that you really couldn't solve it nicely for just y equals. We couldn't make this a nice algebra equation that was just y equals something. So that's why we are going to do implicit. And when we derive, it's just going to be just like reading. Just go left to right and derive as you go. So you start at the beginning of the equation and you work your way through it. So beginning of this equation is y cubed. And so we'll derive that, a nice little power rule, 3y squared. Because it's a y, we'll put dy dx. Plus, and then we can go to the next one, y squared is going to be 2y, put a dy dx. Next, -5, dy dx. Next, -2x, and the variables now are matching with the x's, so we don't have to attach anything. And then this is always just an easy mistake. People get going and they like just copy down a -4, but we know the derivative of a constant is 0. Okay, so this is our first run through. Just left to right, derive as you go. But the question wants to know, what's the derivative? The overall, like if I wanted to find the slope of this equation at any moment in time, I wanted to know my velocity or my rate of change. So ultimately, we need to isolate the dy dx variable. We need to get that all by itself. So if you notice, on the left-hand side, we have 4 different terms. 3 of them have a dy dx. What I do is I keep everything with a dy dx on the left-hand side, and then everything without a dy dx, I put it on the right. So I'm going to add 2x to each side. Okay, so now I've separated my dy dx's from my non-dy dx's. And dy dx is actually a factor. It's something that we've been multiplying by. So now all three of those have a common factor. I'm going to factor it out to the front. So bring that dy dx out of all of those. And then what we have left in parentheses is going to be 3y squared plus 2y minus 5 equals 2x. And then again, dy dx is a factor, so it's this times this. If I want to get this isolated all by itself, I'm going to divide each side by this. So then dy dx equals 2x divided by 3y squared plus 2y minus 5. And then I have my dy dx by itself. I'm saying this is my derivative. And it means all the same stuff it's meant all this time. It's still the slope at any point. I could still put any point in there and get exactly what's going on at that moment in time. But now I'm going to have to know my x and my y to plug in to get that slope. But that's my derivative. So it's some kind of crazy cubic y cubic function. And at any moment in time, that represents my slope. Pretty cool. It's really a bunch of algebra is what it is. Once you get the fact that every time you have to you derive a y, you put that dy dx, then the rest of it, we're just solving for dy dx like you would have solved for x in algebra. Okay, questions right here at this moment about anything you see up there. All right, we're going to try another one then. The next one will look like this. So we've got an equation that we're going to find the slope of, so that means derivative. It's definitely implicit. It's got your mixtures of x's and y's. And then at the end, we're going to plug those values in and get a specific slope. So they're giving us a certain moment in time that we're going to look at. Anybody know what this is a graph of? What? Not a circle because of that 4 in front of the y squared. Ellipse. It's an ellipse. All right. What sign would change if it were going to be a hyperbola? It would be minus in between the binomial. Yep. All right. Just fun facts, for the day. Okay, let's derive left to right. So for x squared, we'll derive that as normal plus, and this derive it as normal, but then it's a y, so we're going to have 8y dy dx equals 0. Okay, now just an algebraic commentary. If you want to move your dy dx's to the right and your non-dy dx is on the left, that's fine. Mathematically, I just like patterns, so I always keep my dy dx's on the left. It will be equivalently the same, but if you move your dy dx's on the other side, your answer, all your signs will be exactly opposite of mine. It'll still mean the same thing. All the signs will just be opposite. So I'm going to move my 2x over and get 8y dy dx equals negative 2x. And then all of these things on the left are being multiplied together. So to get dy dx by itself, I'm going to divide each side by 8y. And so I'll have negative 2x divided by 8y. That's my derivative. So at any moment in time for this ellipse, that would be my slope. Well, they gave us a specific moment in time. Now, just because maybe this might be a non-calculator question and I want to make life easier, I'm going to simplify that derivative before I plug in my point. So I'm going to make this negative x over 4y first. And then we'll plug in the point. So in for x, I'm going to put a square root of 2. And in for y, I'm going to put a negative 1 over the square root of 2. Okay, then I'm going to combine the two things in the denominator. So that'll be negative 4 over the square root of 2. And then I'm going to multiply by the reciprocal of this. And then we multiply across the top. So negative square root of 2 times square root of 2 is 2, negative 2. And on the bottom we have negative 4. So that comes out just to be a nice 1/2. That's my slope at this moment in time. So when we're dividing, we can multiply by the reciprocal. Okay. Anything else on this one right now you're thinking of? All right, let's start another one. I feel like this is getting too easy already. All right, here's what we're going to try next. So not only are we going to find slope, but then we're going to get it into y equals mx plus b. And then what kind of major rules have I now put in the equation? Chain and on the right-hand side, product. Woo, yay. This will be review from what we just took a quiz on. Okay, so it's still an equation, still implicit. We're still going to work our way left to right. So on the left-hand side, this is overall a chain. And so if this helps, still we'll do the inner part is x squared plus y squared. The outer part is 3u squared. So when we go to derive this, derive the outer part first. So we'll have 6, keep the inner, times the derivative of the inner. So then when we go to derive that, we'll have 2x plus 2y and then a dy dx beside that. So that's our left-hand side. That's our chain rule. Make sure we're okay there. Derivative of the outer, keep the inner, times the derivative of the inner. And then equals, okay, now technically there are three things being multiplied together. But one of those is a constant. So I'm not going to do a triple product rule. I'm going to treat this as my first part, and this is my second. As long as your variables are separated into different parts, it'll work. So then for our product rule, first times the derivative of the second. So the derivative of y is 1, but then we put dy dx plus second times the derivative of the first. Okay, so make sure we're all okay with blue and green, because now the next part is just going to be, the middle part is just a bunch of algebra here coming up. So make sure we don't have any questions on blue or green first. Yeah. Yes, right. Now, we wouldn't have to do parentheses if there were no plus or minus, but it can't hurt to ever have too many parentheses usually. But yeah, it's because it's times the whole inner. Yeah. Other questions on any of those parts? Okay, now here's where it gets interesting. Do you see the dy dx on the blue side? It's like stuck. It's part of a binomial that is part of a product. So it's kind of stuck, but we have to do some simplifying before we can get it by itself. We're going to have to end up foiling to get that dy dx all by itself. Now, what I'm going to do is I'm going to multiply my 6 through first, because then I don't have to worry about it later. So I'm going to think about this as 6x squared plus 6y squared. And I'm going to take this binomial times this binomial. So then my goal is I can get all separate terms. I don't want any multiplying binomials. I want them all separated. So when we FOIL, then we'll have 12x cubed plus 12x squared y dy dx plus 12xy squared plus 12y cubed dy dx. So there, now I have, they look messy, but there are 4 separate terms now. And then on the right-hand side, there's not really anything to do at this line, except I will make it 100y, just so it looks better. Okay, now I have 4 terms on my left, 2 terms on my right. I've got to get all the dy dx terms on one side, all the non-dy dx's on the other. And again, here's where, just because I'm a creature of habit, I always bring my dy dx's to the left. But if you decide to switch that up, it's fine. So this guy I've got to move to the right. This guy I've got to move to the right. And then this guy I got to move to the left. And we've got our 4. I missed one, didn't I? Did I miss one? Which one did I miss? Yep, there it is. There it is. Thank you. We got 3 dy dx's, 3 non-dy dx's. Okay, I'm gonna do 2 steps in one. And if you're not okay, I'll go back. But instead of doing another step where I factor everything out and then I divide, I'm gonna go ahead and just divide by all this stuff from the dy dx part. So dy dx over here by itself, on the right hand side I have 100y minus 12x cubed minus 12xy squared, and I'm going to divide it by what these would have all factored out from. So 12x squared y plus 12y cubed minus 100x. Pretty cool. Now we get to do stuff with it. So let's just say this were a non-calculator question and we had to plug a point in. Remember how I said sometimes think about it before you just start plugging things in? Could we make those numbers more manageable for plugging a number in? Yeah, we could take a 4 out of all of them, and then it's going to make the numbers way easier to work with. And if we factor out a 4 from the top and the bottom, those 4's cancel each other out. So we can make this 25y minus 3x cubed minus 3xy squared over 3x squared y plus 3y cubed minus 25x. And this will make it nicer to plug numbers into. Okay, before we do that though, make sure you're okay at the green part. Anything before green that we need to talk about. Okay, the point that they gave us, like 5 million years ago, it was 3, 1. So for all the x's, we're going to plug in a 3. For all the y's, we're going to plug in a 1. And so I'll have 25 times 1 minus 3 times, what's 3 cubed? This was on our quiz yesterday. 27. Minus 3 times x, which is 1, or which is 3 times 1 squared. So just 3 times 3. We'll simplify it here in a little bit. Okay, then on the bottom, 3 times 3 squared. So 3 times 9 times a 1 plus 3 times 1 cubed minus 25 times 3. Now we do want to simplify this because we're doing more with it. That's when we need to simplify more. Yeah. Okay. Then if we simplify those numbers, we've got 25. What's 3 times 27? Good. Minus a 9. On the bottom, we have 27 plus 3 minus 75. Okay, now if we think about this, 81 and 9 are going to give us negative 90. 25 minus 90. What do we think about that number? There we go. And then we have 30 minus 75. Yep. Okay, we've got 2 negatives. So that's positive. And we could, because we're working with this number and possibly without a calculator, we could divide each of those by a 5 to get a more manageable number. What's 65 divided by 5? And 45 divided by 5? Woo! The algebra part and the number part is probably more difficult than the calculus part. What does that number mean to us? Slope. Okay, so we found our slope at this moment in time, 13/9. Now we get to put it in our equation. Y equals mx plus b. So our y was 1. Our m is 13/9. Our x was 3 plus b. And then when we multiply these together, that's a 3. So 1 equals 13/3 plus b. This is a 3/3 minus 13/3. There's our b. Final step. Put your m and your b in. And that's what they want for their answer. Look at all that numbers sense we get to practice. Oh, thirds. I just saw it. Questions? Do we like this better or worse than chain rule? Better? Got a better? This is definitely for the people who like algebra. So Maya. Do we like this better or worse than chain rule? Yeah, it's definitely algebra heavy. All right, we're going to stop there for now because I will show you your scores from yesterday.